everybody, this is Dario Fracassetti speaking. Today I will show you a tool we created for FCA, Fiat Chrysler Automobile, just to give our life simple during the upgrade phase of PI and also of the backend systems. During the backend systems, you upgrade, you have to face the regression test phase that is very complex from a PI point of view. You have to ensure to the customer that everything is working fine, like before the upgrade, and this is very hard, obviously. So we decided to create this small tool just to do in an automatic way all the tests that previously we had to do by hand, each one by one. Just to give you an example, in FCA there are 1,500 interfaces, and for each one you can spend 1 to 3 hours just to make a small test. So in this way we could be faster and safer. This tool starts from an Excel load just to give to the system all the detail of which interfaces you want to run. Then pick up a file from the archival directory of the productive application server, submit this file to two PIs, the old PI, let me say, and the new PI upgraded. Both PIs did the great job, and then deliver to the backend, one upgraded and one not upgraded, the file, and execute all the ABAP proxy and so on. In the end, the tool compares the results on the two receiver application systems. The XML file are compared in the destination system, and if there is or there are some mistakes, error, or differences, are saved into a log table. All that application is running completely in background processing without doing anything. You have just to schedule two jobs, one that executes the interfaces and one that checks the results. Just to show you something, this is, for example, the load procedure. This is very simple, small ABAP import, which load an CSV file into an SAP table. We call it the tool start for support tool for automatic regression test. As you can see, you have just to choose from your front end the file and just load. Okay. And that's it. Then there is an automatic procedure done by the system in automatic that will determine which file the interfaces has to run in automatic way. I mean, when you have to execute an interface, you cannot choose a file by chance. You have to choose a really useful file, a really usable file. So the system will connect to the productive system, download the list of files, take the most recent file, and set it into in our database table just to be used after when the interfaces has to run. This is the report which starts the interfaces. You have some selection screen parameters. You have to set an application server working directory. We choose the TMP directory. And after a few seconds, all the interfaces present in your CSV file will be automatically executed. Just give a small display of the source code. The source code is very structured, as you can see. There are a lot of steps to do. This job is very fast, but did a lot of things. And for example, I have to delete the log, stop both PI channels, read the file from the productive system, check if it's compressed and uncompress it, copy the file to both PIs, activate both PI channels, wait some seconds, and then stop again the PI channel, just to ensure not to pick up any other file. In the end, the timestamp is set into the table, and later on the check report will do the rest part of the compare XML file, check the results, and so on. As you can see, there are a lot of checks before start this report, because it's very important to have every data, for example, the destination created and working, all the file names and directory of the files. Here you can see the stop channel functionalities. That is a web server, or web services called on the Java part of the adapter engine of PI. This part was developed by our colleague Alessandro Frontini. So thanks to him, I had just to put a small perform with a direct code to his web service. We wrapped it into a SE37 function pool. We call the data profile just to add back some parameters like the host name, host port, user and password from the Exchange profile, and then we create the service. We created this class just to, like a consumer proxy, in order to call it from the end of the system. This is the retrieve file from productive PI form. After that, we have to check if it's compressed and then decompress it with a small SM69 command, a Unix command. Then we write the file to both PIs. And after that, we will stop again, start the PI channel, wait for some seconds, and stop again the PI channels. As you can see, we use two constants, the upgraded and the non-upgraded PI. 3 seconds of wait and stop both channels. This is the channel involved in the communication. Very important is to set as external control the channel, instead of the web service will not be able to stop and start it. As you can see, a file has been picked up, and after the web service call, the channel is turned off. Here is the interface running. This is a standard transaction on SAP just to monitor the messages. So we are going to check, and we will see that we have generated 322 messages on the first PI. We will go to the upgraded PI, we will do the same selection, and we will see, luckily, that we have generated 322 messages. So this is the first check to do to generate the same number of messages on both PIs. Here is the second report that checks the interfaces. Also, this report is very structured. This report will execute, will check the results of all the interfaces that the first report ran. So, to ensure that, we created a small status field and a time in order to backshift the search of interfaces to run. This report will do a lot of heavy stuff, so it's better to schedule it background. For example, we'll get the payload for both from both the receiver systems, create a correlation key just to permit to rightly compare the payload, and in the end save the results in a database table. For example, here we can add some parameters. We did an error because there are no data for the extraction, because we used the wrong time shift, it's too high. So now should be fine. takes some seconds because the things to do are really heavy. Try to imagine just to go via RFC on two systems, select the payload, download the payload, take it back to an internal table, sort the table, compare the results, and so on. So, but it takes not so long in the end. Okay. I spoke about the correlation key, and what is the correlation key? The correlation key is an expert command just to understand and create a unique key in both payload in order to recognize them. Because, for example, as you can see before, we generated 322 messages. How to correlate them in the upgraded and not upgraded system? So you have to identify a field in the payload which contain a unique key in order to put together the messages and match them. For example, in our interfaces, we used this command to identify a precise field. Let me show you. This is the field we used as a unique key. Okay. If a correlation key is duplicated, it's not the primary key, and the reports will show you that he found a duplicate correlation key in the backend upgraded. So you have to check carefully because this could be a problem. For example, you are creating a double entry in the upgraded system, and this is wrong. If you want to check what is done, you have to use the money transaction, and as you can see, here we have the disegno. This disegno, it's the same also in the second messages. So you have to do two things, or to change the key, or to check why this key is duplicated. And this is the first step. I did another test with a small file, just one entry, just to show you how it works when everything is fine. If everything is fine, the status is set to finished. As you can see, these are the two payloads, one on the upgraded system and one in the not upgraded system. And just you can have a look, these are identical, luckily. And in the end, I just want to show you what happens if something goes wrong and the two payloads are different. I have manipulated the mapping on PI just to get the result. As you can see, this is the log table in which you will find the errors. There is an error at the row 5, the tag code form. In the first payload has a number, and the second payload has the word inside track. So this is not good. So let's check the payload. On the left you can see the code form in numeric form, the right one, and on the right you can see that there is an error, there is inside track inside of the code form field. And that's it. Thank you for attention.